Cool. So
Okay.
with that, I'm honored to introduce our next speaker, Odin, my former colleague. So Odin is the principal field application engineer at ARM. He is responsible for providing technical and solution services of ARM machine learning and automotive technology. Odin also has US and China patents in noise cancellation, which his algorithm has been applied in several smartphones and notebook product lines. Odin's presentation topic today is Endpoint AI Revolution, driven by standardized computing platform. With that, the floor is yours.
Thanks, Wayne. So, hi everyone. I'm glad to be here. So, it's Odin, principal engineer from Taiwan. I look after machine learning and the automotive technical support. So, as a tinyML developer, I'm sure that Edge AI is such an interesting topic for all of you, because all the developer, they can deploy more and more intelligent on the edge device. Today, I will give you the overview of the Endpoint AI platform revolutions and share some of the exciting open source project with you. So hope you can enjoy the talk and feel free to let me know if you have any questions. As a computing architecture provider, which is more than the 500 of the silicon partner work with us, sparking the work potentially from the tinyML device, smartphone, automotive, data center, to the powerful supercomputer. So our energy efficient processor and the software platform has been enabled additional the 2 billion of the chips. Together with the thousands of the partners, we are in the front end of the AI computing from the IoT to the cloud. So let's start from asking, how did we get there? Artificial intelligence is really kicking off in the hyperscale data center, like we already know that. For example, to identify the content in your picture, you need 1,000 of the picture as a data set to train your machine learning model. The training model will request the massive storage, massive computing, and the really long run times. It could be running most of people to running on the server to discover and decide the new neural network. In the today, and potentially this where will be stay. So every training will happen in the near the data set. But like a tinyML, we are more focused on the inference part, especially for the endpoint AI. So when we're talking about the endpoint AI, it's usually we need to separate the training and the inference and the thinking about they are very differently. Because of we note they are very separately the development requirement. For example, when you do the tinyML, you must be run the inference from the input data in your device. So you can process, you can test locally without the cloud. So the conclusion will be the training may well occur in the cloud, but today the inference will be happen in the endpoint device. So here is such of exciting example how the machine learning use case where inference will change the world across the different kind of segment. I believe during the tinyML foundation, you already see a lot. For example, for the infrastructure, for the consumer device, even for the sensor. They are building of the device today are running on machine learning based on technology. And the people desire to apply the more and more use case into all the device. So let's focus on the machine learning computing first. In order to make the machine learning model work well on the edge device, what type of a solution we have? So the use case, that could be the vibration abnormal prediction. It could be the image object detection. It could be the natural language processing or facial recognition. Lots of diverse use cases have a different input type. It's based on the different neural network architecture. Let's use the autonomous driving as an example. Like the ADAS sensor fusion machine learning model, they bring together the input from the LiDAR, camera around the vehicle. That is a total different than the keyword spotting in your smart speaker. Because of lots of a diverse AI computing requirement, we need a specialized processing. That is a beautiful part can provide. Because we believe that the different computing problems, they need different computing components, such like the CPU, GPU, and the NPU, the dedicated neural network process unit, has allowed all of our partners to develop the system according the emerging challenge purpose. Let's use the automotive system as an example again. Partners, they will increasingly be combined many of CPU, GPU, NPU, and their own IP to generate right computing solution from this generation to next generation. We see the similar things going to the server, smartphone, in all of the computing spectrum. The specialized computes solve the machine learning use case diversity from the hardware point of view. Then let's focus about software, because we all know the success system will become with the hardware and the software co-work together. There will be the nightmare if the developer, they need to use the separate SDK to program each of the computing components, like the CPU, like a GPU, like a dedicated engine. So understand the challenge for all of the AI developer. They desire to use the machine learning, vision, or any other kind of compute feature across the same ecosystem. That's reasons also provide the universal software stack. The open source, they include the framework, inference engine, and the neural network library, which is enabled all of the machine learning use case deployed to a wide range of the segment and application. Those software will be the open source and quarterly released. I think you may heard a couple of times, the CNC CNN. CNC CNN is an optimized library for most of the common machine learning library, targeting for all of the Cortex M processor, no matter from the Cortex M0 to the M55. Let's use the real TensorFlow-like workload as an example. The CNC CNN kernel provides more than the 4 times performance and 5 times energy efficiency compared with the non-CNC CNN kernel at same hardware. That means you can use the open source CNC CNN to dramatically improve your machine learning on the tinyML. So use the CNC CNN framework. Developer can easier to deploy a lot of machine learning model for all of the Cortex M processor. Now, let's focus on tinyML segment. Here's several examples you will already see a lot, which is running on the machine learning running on under 1 millivolt, like object detection in the drone, like abnormal vibration detection on the sensor, or smart speaker keyword spotting. There are thousands of the developers they are using the Cortex M hardware to create their creative. As I mentioned previously, AI demand is diverse. So only apply the standardized software stack may not fit all of the tinyML requirements. So when the developer consider to develop a more complexity neural network model with the resource constraint device, what the challenge will be. So typically, the computing power is the main critical part for the tinyML device. most of the tinyML device only provide 1 meg or 2 meg per cycle, which is way behind developer need. Also, like the professor, the previous session mentioned, the memory capacity for the MCU device is another challenge to apply more of a more complex machine learning model. Based on our investigation of tinyML use case analysis, we realize there's many kind of different type of workflow in the MPU. For example, audio abnormal detection, it took the 75% of the computing resource on pre or post audio processing. Only 50% of the computing used by the excuse me, is some sound? Let me go ahead. So on the other hand, like DTV super resolution quality enhancement, there's more than 80% of a resource constraint.
Apologize for the inconvenience, Odin. Could everyone mute their microphones? We have some background noise here.
Yeah, there's some. Yeah. Wait, should I continue? So.
Rosina, are you able to mute everyone? Yeah, sorry about the inconvenience here. I don't think I can mute everyone.
Okay. Let me go ahead, right? Okay. So to respond to the industrial need, last year announced the significant endpoint AI solution. Cortex M55 is the latest Cortex M processor. It's the V8.1 Helium architecture with the included MBE, vector extensions, and the 32-bit SIMD instruction. They included 8-bit Mac operation per cycle, which is a significantly improved the convolution. So also the TVN and the instruction and data cache and the ASI interface also enhance the machine MCU, the memory throughput. So for the ecosystem, they require the more high performance machine learning computing. On the right hand side, the dedicated neural network processor NPU, they will also dramatically improve the efficiency and the performance. Both EaseU's 65 and the 55 are configurable and scalable to address the tinyML diversity. Partner can set up to the 32-bit to the 256 meg per cycle. These IP combinations has been released. The several partner has been announced they are using in their coming product. So here is some of the example. You can see that the 6 times the voice inference improved from the Cortex M55, and overall the 50 times the improve with the additional EaseU 55. So let's talk about what would be happen when we added more of the EaseU process into the machine learning. It's a similar But basically, developer will reuse the same TensorFlow-like software stack, just added one procedure under their host site. The neural network optimizer identified the graph to run and did the optimization, scheduling, and the allocation for loss of graph. After TensorFlow-like runtime running on the device, the only thing you need to do is make sure you already included EtherU driver in your systems. All other software procedure will be kept the same. Now, I'm so excited to give you some new stuff. So since the machine learning use case is continuous iterations, the tinyML software developer flow is more like the child. So start from the left, we see the data stored in the cloud and used for the training for the neural network. The neural network model will go through the process to the optimization, such as the pruning and the quantization the professor mentioned before. That can be reduced the size of the fit into the resource constraint device. The neural model will need also be integrated with the rest of the software, package it to the binary, and finally to deploy to the device. This device will be in the field, will keeping monitoring or added on novel data to improve the model performance and the quality. So traditionally, the embedded developer flow may not be longer to suitable for the tinyML, the ML-oriented developer flow. For that reason, also announced the virtual hardware, which is a simple and a scalable way to remove the dependency from the hardware and unlock the cloud-native developer. You can imagine that virtual hardware could be the equivalent with the virtual machine for the IoT for any of the Endpoint AI device. The virtual hardware provides the functionality accuracy of the ARM-based SoC, simulation the behavior from the software perspective, but keep the abstraction to the complexity around the underlying hardware. The virtual hardware is targeted to run in your local machine as well in the cloud. So apply to the virtual hardware, what the software development flow will be. You can see in the left-hand side, the virtual target can be leveraged to estimating the performance on the optimization machine learning model directly in the cloud without any actual hardware. That means that all of the AI developer, they don't need to rely on the real hardware to do the optimization. They can use the cloud and with some of the functionality equivalent model. That's also enable you can easier to try different kind of network configuration and to try to continuous optimizations. From the other software developer, the clear advantage will be they don't need longer to use the board in their desk. You can use the virtual hardware to do the software porting. Another advantage will be the CI, the continuous integration. You can have a more ability to run and scale your testing. No more bottleneck during the broken board or the power supply. If you want to join the virtual hardware for even the DevOps or MLOps, now you can. Just go to the virtual hardware website in the screen and follow the instruction. They can run your own model of the IP I mentioned, the Codex Amplified and the U55 directly in the AWS cloud. Not only the software developer, you can also use the virtual hardware for the performance benchmarking. The slide show here, you can configure the different type of the mega operations. You can configure different kind of the memory latency and other kind of parameters to help you to earlier to understand your machine learning performance on the endpoint device. In this session, we start from what the machine learning needs and introduce a couple of the tinyML solution, which can help developer success into the AI. But one beautiful piece to success you, the developer, and all of the ecosystem partner. We know that is all of you to make this foundation to success. As always, as continuous engage of all the ecosystem partner around the world, our partner program is expanding all the time. We see a lot of ecosystem alignment across the common platform. As a developer, I'm sure you're eager to know when the Codex M55 and the ESUS U55 platform will into the market. Here is some public announcement from the developer for your reference. I would like to highlight one of the tinyML member, like when mentioned before, HiMax. HiMax is leveraging the Codex M55 and the ESUS U55 to maximize the edge computing with the single tool chain from ARM to significantly speed up the ultra-low power smart camera solutions. Stay tuned. More of the product will come into the market shortly. I think we all believe that AI is a generation change in computing. That will be the change of everything from cloud service to the tinyML device. This shift will unlock creation of value. That will make the existing application better, faster, cheaper, and easier to use. And they will make all it possible to achieve in the small and the low power device. And the more beautiful part, they will also enable the whole new use case. Is reducing the risk by providing Endpoint AI building block and deliver the open source software and the tooling to make everyone can enjoy the tinyML. Hope you can enjoy today's section and let me know if you have any questions.
Cool, thank you, Odin. So if our audience has any questions, please use the Q&A window at the bottom of your Zoom window to raise your question. So I think we have one question here. You mentioned the same CCNN. What's the difference between same CCNN and the Google's TensorFlow Lite for micro?
Okay, that's a good question. So I think that would be from the software point of view, that would be the different layer. The TensorFlow Lite, that would be some of the framework layer. They can have the chaining framework and also the inference framework. And the underlining, once the TensorFlow Lite runtime, they want to deploy to the endpoint, the backend. The CNC and then provide the well-tuning the low level driver. So, for example, the TensorFlow Lite, you don't need to consider about how to optimize the quantization operations in the Codex A. The CNC and then will take over that.
Thank you. Next question: can you name any silicon suppliers adopting U55?
Okay, based on the public information, we have at least 3 and 4 partners. They already applied the ESUS U55, but as we cannot comment that some of the project that our customer they are doing now. So yeah, for example, the ELF. So the company already have the chip in some of the engineers temple. They are basing the Cortex A, Cortex M, and the ESUS U to build out some of the sensor fusion solutions. Also, the NSP, they also announced they will use the ESUS U55 and 65 in the further the product line. Also, the HiMax I mentioned before, their new product, the ultra low power smart camera, will based on the U55. But not that's all. But we still have a lot of partners, but we cannot mention here.
Okay, so next one, on the virtual hardware, can we measure energy efficiency? A great question.
Yeah, that's a good question. So I think the power consumption is one of the concern from all the developer, right? But so far, this is undergoing products, undergoing processing. So now we are focused on like the memory transaction where the cycle count, but not directly the power consumption. So that would be some of the plan, but not happen in this moment.
Okay. Next one, can U55 be used as an accelerator with other cores, such as Cortex M7?
Okay. Oh, yeah. Yeah, I should mention it more clearly. So users use the NPU, they can, along with any kind of the Cortex M processor, from the Cortex M4 to the M55. I use the M55 just an example because it's a more powerful machine learning. But we also see that some of the partner, they will use the ESUS U55 with like the M33 or M7. This also work.
Cool. So since it's an NPU, only focus on processing convolutional neural networks for image and video type of use cases, or can they be used for other algorithms such as RNN, LSTM, or tree-based machine learning?
Yeah, that's a really good question. So talking about the traditional the convolutional neural network base, talking about RNN or LSTM, we have some flexibility to do that. But at this moment, that some of the operator will be the fallback to the CPU to compute it because the IP itself is fully supported CNN. So the answer is it could be, but the some of the layer should be fall back to the CPU to process.
Okay, thank you, Odin. So if there is no further question.
Wait, can I ask one last question?
Sure, go ahead.
Yeah, thank you.
Sure.
Thank you for great talk. So I just have one question. Does CMC support binary weights or something, or any future plan for that?
Can you say again?
So this CMC framework, right? Does it support binary weights or ternary weights? Because I'm not sure whether it supports that. So just, or any future plans to do that?
I think we have a plan to do that, but maybe we'll get more precisely what is the future you are considered. So in the CNC system, we have the GitHub link. If you have some requirement, feel free to ask in there, and we will keep our eyes to add more of a future from the ecosystem. Yeah.
Yeah. Thank you.
Check.
Cool. With that, thank you, Odin, for a great presentation. So ARM also has a partner session on day 3 of the conference. Come and join the session if you want to learn more.
Yeah. Thank you.
I also want to extend our gratitude to all the tinyML strategic sponsors who made this event possible. At the executive sponsorship level, we have ARM, my old employer, who provides the software and the hardware foundation, tinyML. Edge Impulse is the tinyML platform for all developers. Qualcomm advances AI research to make efficient AI ubiquitous. Sentient offers end-to-end deep learning solutions for tinyML and Edge AI. At the Platinum sponsorship level, we have Reality AI adds advanced sensing to your product with Edge AI and tinyML. Renesas, who has big ideas for every space. With our golden sponsors, Latent AI develops adaptive AI for the intelligent edge. Maxim Integrated, who is now part of Analog Devices, enables edge intelligence. Seed Studio, they are the IoT hardware enabler. CCNC builds smart IoT sensor devices from data. SynSense builds sensing and inference hardware for ultra-low power devices. We will have some special partner sessions in the next few days, led by the sponsors we just introduced. At the silver sponsors level, we have Aeon Devices, Deep Light, AMSA Vision Sense, GreenWaves Technology, Gravity, HOTG, Imagine Mob, Kixel, Rexin, and SAP.